let's go. So thank you for the kind introduction. So I'm going to present you the prospective use of in situ coupled hyperspectral and laser grammetry imaging system, which is the work of our third year PhD student, Julie Fromager. Normally she should have presented herself this presentation, but she is right now in Toronto, in Canada, to present her work at the ISPRS conference, so I will try to be a good substitute. This project is in partnership with between the CY University and the Versailles capsule with Danilo Forleo, as you just said. And just to precise, this project is funded by the Fondation des Sciences du Patrimoine for the PhD thesis. So here is a brief overview of my presentation. I will start with the double origin of the project, with the HyperPICO program and the Espadon project. Then we will move on the scientific challenges of the HyperPICO device. And finally, I will show you some first results, as it's still an undergoing project. So for the incipit, let's take the Versailles Palace Queen's bedroom. In this bedroom, we have a new risk situation to identify because of the climate change, because we have multiple heritage objects that are displayed in open air environment, and because of the different climate conditions regarding sun exposure, air conditioning system, and everything like that, we have some degradations that are appearing quicker than before. And here is a non-exhaustive list, but we have seen more degradation with appearance degradations, geometric alteration implying the underlying structure with delamination and warping of paintings, for example, or of hangings. And also we have a question about the water retention roles of the different heritage materials like wood or fabric. This is accompanied with more infestations problems with molds and pests. And this is to what tries to answer the HyperPICO program. This program is led by Danilo Forleo and tries to rationalize the problem of the sampling, because as we have a huge amount of objects to study, it is necessary to try to rationalize this. And he developed a methodology inspired from epidemiology, integrating multiple risks and constraints like the preservation conditions, the state of the collections, and the museography. The idea is to identify the most representative object to diagnose and then to propose some corrective actions. The main objective is to have better preventive conservation strategies, finding the trade-off between contradictory goals, notably climate change, heritage conservation, energy efficiency, and sustainable development, with a current hot topic about the air conditioning system or not. To support this program, we need some new tools to have quantitative evaluation of the collection states to go further than the visual estimation of curators. And the idea is to be able to study the causality between the climate conditions and the degradations. And this is the second origin of the project. The HyperPICO project is based on the Espadon program, which is an equipex in the French referential, and tries to foster the concept of the augmented heritage object. I won't be really exhaustive about this project. The main idea is to consider that we have some contextualized heritage objects that are coming from museums and collections. These objects can be seen from the scientific point of view with a constellation of data, methodologies, analyses that are gravitating around the material objects. And if we merge all of these aspects with spatialization notions and semantic links, we can have an augmented object that will foster and be valued towards the general public or professional sphere to be valued. The HyperPICO project is included in the Espadon 1 regarding those two aspects, the data aspect and the analysis aspect, because we are developing and testing a new tool in situ to have more data about the object, and we analyze those data with the climate conditions. And it goes also towards the spatialization, as you will see, we use a 3D LiDAR camera to spatialize our data, our hyperspectral data. So this is the HyperPICO device. It's a gonio hyperspectral camera. Why gonio? It's only because the camera is a push broom camera that is mounted on a rotating stage. So we take one line of spectral data, we move on, we take one spectral line, we move on, extra, etc. So there is a first challenge about the reconstruction of the data, as we have a cylindrical projection of our objects. Another challenge is that the camera has a constrained field of view, so to obtain the full field acquisition of the object, we have to perform multiple acquisition and then to merge those multiple acquisition. What is the spectral range we choose and why? Evidently, we focused on the visible light to have the true color rendering of the object, but we also add a camera in the infrared radiations. The first camera ranges from 400 nanometers to 1000 nanometers, and the infrared camera ranges from 900 nanometers to 1700 nanometers. With this spectral range, we hope to achieve a characterization ranging from the macroscopic scale with appearance and structure to the microscopic scale with physico-chemical characterization of compounds and an intermediate scale like biological contaminations like mold or fungi. And now, what is the methodology of the project for the PhD program of the student? The idea, as I said, was to correlate the hyperspectral data with climate data. As a consequence, we choose the following methodology. We have done some seasonal measurements during spring, summer, autumn, and winter. For now, we have done a full cycle, and we hope to have the second cycle at the end of the year. We worked in two different rooms, the Mercury Salon and the Queen's Bedroom. Why those two rooms? Because they have some different conditions, notably regarding the sun exposure. The Mercury Salon is exposed to the north, while the Queen's Bedroom is exposed to the south. And the Queen's Bedroom is equipped with an air conditioning system, while the Mercury Salon is not. We were able to acquire 5 objects in the Mercury Salon and 6 objects in the Queen's Bedroom, which is really less than what we hoped to do with the HyperPICO program, as the HyperPICO method would advise to characterize 30 objects, but the acquisition times are quite long, and we have to do the measurement campaign during the night when there is no public in Versailles, so we are really tight by the time of the measurement sessions. And what data finally we obtain? We obtain calibrated infrared and visible reflectance for each object, and a 3D point cloud for each acquisition of hyperspectral acquisition that we will correlate with the climate of the rooms, with the room temperature and relative humidity. As I said, the main challenges are regarding the data processing, and notably the data alignment, because we have multiple data clouds. We have a visible data cloud, an infrared data cloud, 3D data cloud, and we have to merge all of this data. We have also to merge all the different position of acquisition for each object, and then to replace all this data regarding all of each campaigns. So I will try to move on quickly on the results. First, we have done some in-lab tests to see if we were able to be sensitive to a real modification in physical chemical signature of the furniture in the rooms. To show you some examples, we worked on the wood moisture content with 6 samples of tropical wood from the tropics database of the CIRAD. The protocol was the following. We dried the samples during 3 days to 1 week to be sure that we were in annealed condition. And then we made the sample undergo some relative humidity steps of 20%. So as a consequence, we had a range from 20% to 80% of relative humidity in the room. We processed the data as the following. We removed the baseline to get some peak extraction, as you can see on this figure. There is multiple peaks. There is one around 900 nanometer that is not really clear for now because we don't have it on all the samples. We have also a peak around 160 600 nanometers, which is due to the instrumentation because we have seen that we have a small problem in the calibration of the device. But what is really interesting is the following. We have a first peak that is surely associated with the aromatic groups, and the one of interest for the wood moisture content, which is the one at 1400 nanometers. And if we look to the peak area under the curve, we can see that there is a decrease of the peak area and that we are sensitive to the wood moisture content. So now we have to see if we are really sensitive to this wood moisture content in situ. Another result in lab was about the colorimetry and gloss estimation. This was done in a student project in collaboration with the Institut National du Patrimoine in Aubervilliers. It's a project from a student for her master thesis. She worked on photographic collodion sample flaking, and the idea was to see if we were able to prove that there is an impact or not of consolidant on the appearance properties. We only used the visible hyperspectral data and were in close-range configuration. Here is an example of the samples we worked on with the true color rendering. What is interesting is we are able to create those true color rendering without any chart of calibration. It's just from the calibrated visible data. But what is really interesting is that we were able also to extract the rugosity of the samples and to see what was the region of interest. And we chose some points in the really cracked parts and in the not cracked parts. And here is the results for 3 different indicators of the gloss. We worked on the mean reflectance, that is in the above figure. We worked on the anisotropy of the angle anisotropy and on the reflectance contrast. And the global result was that there was no impact of the consolidant on the appearance properties, so she could use any consolidant to perform her restoration on the real artworks. Now I will show you a really preliminary result, still in colorimetry, but of the hangings in the Queen's bedroom. So I just took a free zone between conserved sample and the exposed real samples to compute the lab parameters. And even with really bad and brutal data processing, we can see that we are sensitive to small variation of the lab parameters. A better solution would be to work with superpixels to compare the region of interest point by point. And finally, here is our most recent results. We have finally achieved in the last few weeks to merge the hyperspectral data with the 3D point cloud. And now we will have to use this specialized information to have better results in the correlation between each point clouds. So what are the perspectives of the project? We have to improve our reconstruction projection between the hyperspectral and the LiDAR camera data. The idea is to fusion all of the clouds that we acquired during the last year over the acquisition, object, measurement session. And also we have to handle the misplacement of acquisition, because even if we try to be the most precise possible, we still have some difference in the placement of the hyperspectral camera from a measurement session to another. So we should have some differences in the value of the reflectance. Then we have to have better extraction of our lab parameter, for example, but also of physico-chemical characterization. And maybe we have to think about an automation and a segmentation of the data clouds to finally have maybe some links between the climate data and the hyperspectral and 3D camera data. Thank you for your attention, and sorry if my English was a bit rusty today.